Thank you. So, sorry, it's me again. Thanks. Okay, QGIS. I mentioned before that it's important to put a lot of effort and passion into projects, and QGIS is one of those examples. Back in 2002, Gary Sherman decided that it needed viewer for his PostGIS data, and that's the first commit message that that he did. He said, well, here's QGIS, it can display spatial data, and there is no editing, there is no whatever, it's just display. And that's what QGIS was back in 2002. And I'm going to fast forward to 2022, because last year I gave a talk in Firenze about what happened between 2002 and 2022. So if you want to get that information, you can go and look for the talk. What I want to talk to you about today is really more about what happened since, like 2-3 things that happened between Firenze and now, but then mainly what we are looking at for the future. It's not going to be about features, so if you're looking for features, I think Kurt has a feature-related presentation when? Tomorrow. So don't miss that one, because that's a lot that happened in there. I'm going to talk to you more about the project as itself and what we are trying to achieve. I said we were in Firenze. Was the first time we met again after COVID. It was 20th birthday of QGIS, so we were really all happy. That was, to me, a really nice moment to be back in the community, to see people again. And one of the highlights of the year, the other one, for me, the year I mentioned before already, and it's not completely QGIS related, it's in the ecosystem of QGIS, is that QField won the Best App Award, and I was in a room like size like this, and it had like screens all around it. It was QField and QGIS logos everywhere, and I was like, okay, wow. And then the other big highlight was that we finally managed to do the Hackfest 2020. We all got a nice t-shirt saying Hackfest 2020 or Contributor Meeting 2020 in 's-Hertogenbosch in Holland this spring. And we had about 150 people there. We did 2 days of conference, and then we did 4 days of contributor meetings. So that was really, to me, again, the kickstart. Okay, the community is also physically back. And now we are in Prizren with QGIS 3.28 LTR being out, 3.30 it's here, 3.22 it's actually also already here, but as a release candidate, that's why I put his coming. It's really something that it's very close. So we got these amazing versions with heaps of things there, but that is not what I'm going to talk to you about. What I'm going to talk to you about today is about how much of an impact QGIS is doing and what we want to do to make it last longer. We've added very little data analytics on what people or what kind of QGIS instances are there. Basically, when you open up QGIS and it loads the feed, the news information, QGIS is telling the server which operative system you're using, which version of QGIS you're using, and obviously via the IP where you're located somehow, country-wise. We do a bit of statistics on this, and what turns out is that we are doing over 500,000 openings per day. And that's people that are opening QGIS and seeing the newsfeed. Means people that are behind the firewall, not counting. People without internet, not counting. People like Kurt that keep on his QGIS open for months, probably, because it's always open, not counting. So we I don't know, I have no guesstimate on how much more actually we are doing, but even only those people that are opening actively QGIS every day or once a day, we're doing 600,000 people per day, or 600,000 opening per day. So it's pretty big number. And this is to put things in relation to how efficient we are actually managing the project. QGIS has a budget of about 220,000 euros per year. And that includes all the infrastructure that we are running, every server, everything, website, downloads. We are 40 terabytes per month of just pure downloads of the installer. We're doing really big numbers, big things, and we are managing it with nothing, with a very small budget. And the other thing that we recognized is that QGIS is a highly professional software and shows the classical professional usage pattern, which is nobody works on weekends and everybody works during the week. This is across the year. We are seeing this. It's always like that. It's clear. We go from 150,000 openings up to 650,000. So it really varies a lot, and that's where you see that people are usually using QGIS during their Monday to Friday. So you can assume that they are probably using it at work. We still have a baseline of very committed people that maybe are doing also private projects or maybe work on the weekend, whatever. But it's a very clear pattern that it is not just used by people that in the weekend are doing their mushroom findings maps. So it's really something that has been used a lot. And that is why we, in the PSC, decided at the beginning of the year that we need to do something. We need to increase our budget so that we can serve our users better and we can be here for the next 20 years. Because as I said before, for a company that relies on QGIS, it's much cheaper to help QGIS now than have to migrate to another kind of tooling later on. And in in January, sorry, we started a crowdfunding to get more sustaining members. So QGIS.org has this concept of sustaining memberships, where every year you donate to the project and it supports all bug fixing programs that we do, the grant program where we do, the infrastructure that we do, all the web stuff that we are building. So it's really a lot that we do with that. And we managed these, thanks to this crowdsourcing, to go from about 130,000 per year that we had coming from sustaining membership. We managed to add actually 70,000 more. So pretty happy about that, but still there is room for improvement. And what we did this year already with the little more budget that we managed is that we identified 2 places where QGIS is a bit lagging and where we needed full-time work power. And that's the first time ever that QGIS allocates resources to 2 persons to work full-time, one side on documentation and on the other side on the web development, kind of all the plugin infrastructure, all the website and so on. So this is really kind of the long-term goal, is to also have a bit more of this possibility where we can say, well, we have a PRQ maintainer that has an allocated time. So really going into that direction where we know that people also have the time to really invest it and to know that it's full-time, they're there and they have the responsibility for it. Obviously, to get more sustaining members, we can, on one side, obviously go and do crowdfunding, try to involve the community more, and that is good. But what we also, that's kind of a personal mission for this and next year to me, is, and we'll see later, we'd like to engage with larger bodies. We know that very big companies are using QGIS a lot. And we know that our budget could be doubled by them in nothing, basically. But we don't have yet, I think, the kind of appearance to be able to go to a decision maker of a big company. So what we're trying to do is to sharpen our language. So we're trying to really go in a direction where we say, look, hey, this is QGIS, that's the best GIS out there. You need to get that, and you need to support us. And to go in this direction, we started working on different things. On one side, we started working, back in Firenze, actually, we did the first workshop on vision and mission for QGIS, what we stand for, what we want to stand for. And this is the continuation of it that we did in Den Bosch. You see here the kind of subjects that came out of the first workshop, and here kind of the result of the second workshop, where we have the three subjects that we want to bring into our mission, our vision, and it is clearly best GIS is in there. For the people, by the people, so the whole community aspect is very important, very rooted. But then the main point, and that is what QGIS wants to stand for, is empowering. We want to give people the power to do things, to solve their problems, dealing with some sustainable development goals, making their company more productive. We don't really want to have any opinion on what people should do. We want to empower people, to give them the possibility to do and to deal with what they have to deal. It's really an important thing to think. We don't want to become service provider. QGIS does not want to become a service provider. That's not our DNA. We want to build the best GIS that empowers people and that has a fantastic community. So this is what we don't have the final sentence that kind of embodies what I just said, but the content is going in that direction. What we do have is a new claim, and in the background you see a lot of screenshots of a website that you don't know, because that's the new website that we are building, and I'll show you a little bit more later on. We do have finalized a new claim for the website, which is spatial without compromise. That's going to be more like the marketing message that we want to bring out on the main page, and so that we really also here see, well, it is spatial, obviously, and the without compromise has a couple of meanings. I'll let you interpret which one feels best to your needs. I said that the new website is being worked on. We have a full, oh, that's fast. But it loops, so we have time. We have a complete working design mock-up. Basically, now what we need to do is go from the design mock-ups into an actual website. What is important here, and I'm sorry that it's scrolling that fast, usually it scrolls, we must have a monster machine there. What we are really looking at and want to showcase is that we have different subjects where QGIS is very well working. So we have the mapping aspect, we have the editing aspect, we have the analysis aspect. So really putting out what QGIS can do for you if you don't know QGIS yet. So the idea is that QGIS.org, the main page, will be a page for people that do not know what QGIS is and quickly get an information and all the insights about what QGIS can do for them. Obviously, empowering is here, the open source concept is here. So really see it as a page for someone that doesn't know QGIS yet. Everything that we have on QGIS.org now, the documentation, all the community stuff, that's going to stay, just going to be one step behind so that we can simplify things and we can really give this polished image of QGIS to people that do not know yet what it is. So that anybody can go to his boss and say, go to that website and you'd see why I want exactly that tool, because that's the best and that's what we need. The goal, as I mentioned before, is to engage with more larger companies. We had, thanks to the crowdfunding, we got our first ever platinum sponsor felt. So really happy about that already. Obviously, we want to grow that. You saw on the website before that up at the top there is trusted by. So this kind of the idea to have really big companies also use, or actually acknowledging that they are using them, because we know, and I'm gonna show just 2 examples without making names, but if people know numbers, then they might understand. So very large search engine company has released a video on how they place their fiber across the Atlantic. And if you look keenly on the video, at a certain point, you just have a blatantly clear image of QGIS being used for knowing where the transatlantic fiber cable are placed. And that's obviously something that makes us proud, obviously, as a project, because it means that, hey, that's pretty freaking big deal. They're carrying a 30 terabit per second with that cable. So it's YouTube. So what they say in the video is that the YouTube video that you are looking can be streamed 4 million times parallel through that cable in full HD. So just to put in, and that's placed with QGIS. So I think that's a pretty big argument. And then another company that is here also as a sponsor, they're even giving tutorials on how to do data for good with QGIS. So we really know that, and I leave you the numbers for the geeks to try to understand what the numbers are. But it's really, we know that big companies are using those our tools. So we really need to engage with them more and more. On the other hand, obviously, we still need community. It's not only big corporations that give us money. We still, and that's the beauty of QGIS, is that we have this dual aspect of highly immense companies, and then we have somebody that really is making his map of where did he find mushrooms last week, and that is really this fantastic mix that we cannot lose, because it's what makes the project community so rich, is this different perspective and all the companies working together to develop together with the volunteer work. So it's to me, it's a truly amazing, and I'm super honored to be the chair of this community, because it's really what you try to do. You're juggling complete opposites. You're juggling somebody working a night after his work with somebody that is just doing it as part of a corporation. And this we cannot miss, just because we are looking at larger entities. And that is why getting involved as a small grain of sand or as a small seed is very important. And here you have immense possibility. You can help document. You can help translate. There's so much work happening there. We have 234,000 strings that are translated in something like 27 languages. So just coding is one part, but these things, documenting, translating, answering questions to people, that's all work that QGIS itself as an organization cannot do. It needs people to help out, and that is really where everybody can help a lot. Commenting on enhancement proposals. So when you are, when we do bigger change, we always go through this process, and that's maybe something also for if you hire a company to do something in QGIS, something bigger, make sure that they go through, they should tell you that they are going through this process, because that's the process for making larger change in QGIS. Report issues, even better, solve them. What we said in Den Bosch is that we don't want to report issues, we want to get pull requests. That's optimistic, but you need to aim far to get somewhere. So reporting issues, important thing, if you report issues, use the search button before reporting a new issue, because that's a really important thing. Get commercial support. There are plenty of companies that do offer some commercial support. The good thing there is that they usually bring back a lot of things to your to QGIS itself. Get training. We have a certification training program where if you're getting an official certifying company to certify you, for every certificate that they are giving out, they are going to pay the QGIS project back. That's also a big source of income for QGIS. Obviously, become a sustaining member. That's the best way to support the project if you can, or have your company become a sustaining member. That's really important to us. And yeah, basically join the project, help out. There's so many things you can do. Even if it's only networking with other people and telling them that they could help out. I think that's it. If you have any questions, get in touch here, or I'm going to be all the week at our booth inside, so come by. Thanks.
Thank you.
Any questions?
Hi, Marco. Just curious if there's a timeline for the release of the new website yet.
I can quote Tim on this. Yes, there was, but it passed. No, actually, the original timeline was really to get it ready by the end of the year, last year, but it was completely utterly unrealistic. We're now looking more at this end of the year. Yeah, it's the main thing is that really now we need if anybody knows a very good web developer, a web designer, we'll be happy that wants to help out. We'll be happy to talk to that person. Yeah, that's the main thing that we're lacking. We have the backend is there, the mock-up are there, so we need to get the mock-up on the backend. Thank you.
You're giving the talk? Okay, perfect. Martin Landa, okay. Good. Okay, so moving on, the next talk will be by Anna Petrasova, Václav Petras, Veronika Andreu, Markus Nettela, Martin Landa, State of GRASS GIS, and the talk is going to be given by Martin Landa. Stage is yours, Martin.
Thanks. So can I ask you to switch, please? Or I should do it somehow? I mean, it's in Google. And it should be open there. Yeah, the first tab. Thanks a lot. First tab, please. Okay, thanks. And can you just go to the first slide, because this is the last one. Thanks a lot. Okay, so good morning, ladies and gentlemen. I would like to present here the state of GRASS on behalf of GRASS community. Let me also thank to my GRASS colleagues and friends who contributed to this presentation. So, yeah, next slide. I will try with the mouse. I can just switch, or how can I can switch, or you will do it for me? Okay, I will try. I don't see the mouse. It doesn't work. Yeah, but I'm moving with that, and doesn't move at all. So if I can just ask you to press the space and just, okay, great. So go back, please. Thanks a lot. Okay, so my name is Martin Landa. I'm working at the Department of Geomatics, Czech Technical University in Prague. I started to use GRASS and to contribute to GRASS in 2003, so it means like 20 years ago, which is half of my life. So you can imagine that, I mean, GRASS is like part of my heart. It's half of my life I was just helping to GRASS to be better. And it's a special moment for me here to present GRASS here. You can see from my contribution that in 2017 I switched to another project, which is my family. So you can easily see that my contribution to GRASS went down. So this moment is like nostalgic for me that I can present GRASS here, and it's a honor and pleasure for me. So please, next slide. So what I will go to present here, first of all, I would like to present GRASS, what it is for newcomers. Then I will present a new features in GRASS 8.3, which is like a newest version of GRASS. I will also highlight community contribution. I would like to share with you, I mean, the approaches, the ways how you can be involved in GRASS. And at the end, I will present, I mean, how we celebrated GRASS 40th this year. My colleague Marco, he was presenting that the QGIS celebrated 20 years last year, so we celebrated 40 years this year, which is quite extraordinary. So please, next slide. So what is GRASS? GRASS stands for Geographic Resource Analysis Support System. It's open source and free software GIS used for geospatial data management, analysis, image processing, spatial data modeling, and visualization. It's very powerful in geospatial data processing. It was originally developed in early 80s by the US Army, and in 2006, GRASS was a founding member of OSGeo. And as I mentioned, this year we are celebrating 40 years of continuous geospatial development. If you just visit our GitHub repository, maybe you could be disappointed because, I mean, if you just search or look at the history like the first commit is like in 2003 or something like that. But I mean, there is a separated GitHub repository, which is called GRASS Legacy, which really contains the history till, I think, GRASS 3 is the first version which is included. So if you are really interested about GRASS history, we have separated GitHub repository which contains almost full history of GRASS development. So please, next slide. So GRASS is really powerful, as I mentioned, in geospatial data analysis. It contains more than 400 tools which allows you to process your data. There is also, I mean, beside of these core tools, there is more than 400 user-created tools which are called add-ons. So I mean, everyone can contribute to GRASS via these add-ons. So please, next slide. So about the roadmap, last year in Firenze, my colleague, Markus Netteler, was presenting the version 8.2. So it's a pleasure for me here to present the new version, which was basically, or actually, released a few days ago, 1 week ago, GRASS 8.3, which brings nice, cool features I'm going to present in the next slides. I just wanted, or I would like to describe how we are versioning GRASS. We are using a semantic versioning approach. So the version contains three parts. The major parts, which brings new features and possibly backward incompatible changes. The minor version, which brings new features and fixes, and the micro version, which brings only fixes. We change the way how we are using the odd and even minor version. I mean, till GRASS 8.2, we distinct between odd and even minor versions in the way that, I mean, odd versions were used for development phases, and even versions were used for release. So it means that, I mean, if you just check the roadmap, there was GRASS 8, and the next release was GRASS 8.2. We changed that with starting with 8.3. We are using every minor version for release. So this year we released 8.3. For the next year we are planning to release 8.4 and so on. So this changed, so please don't be confused from that. So please, next slide. So I was mentioning that there is a new GRASS version, which was released just 1 week ago, 8.3. So let me present just selected new features. I mean, for complete record, just go to the GitHub and check the news, which contains, I mean, full list of changes. So please, next slide. So first tool I would like to present is Vornoi, which is a GRASS tool, and I mean, in a GRASS 8.3 version, it allows to create skeletons and center lines. This improvement was done by Markus Matz. Please, next slide. Also the module which computes a different type of vegetation indices was improved. This tool is called i.vi. There's a new support for soil line slopes done by Andrzej Peszek. Next slide, please. There are also plenty improvements in graphical modeler, which is one of graphical user components. This new feature I'm going to present here, the GRASS graphical modeler allows to export your model into the WPS process, so you can easily convert your GRASS model into the WPS process provided by the WPS project. So please, next slide. There is also Jupyter Notebook integration in the GRASS environment. It was introduced in version 8.2 last year, thanks to the Google Summer of Code project. GRASS 8.3 comes with various stability fixes, and there is also like a new feature which is called Series Map, which allows to use in the notebooks animated vector or raster series. It's still hanging the pull request, so this is still some work is ongoing. So please, next slide. There's also faster support for external data sources. I mean, GRASS is using its own raster and vector format, but beside that, I mean, you can easily read external data formats in GRASS thanks to the GDAL library. So you don't need to import your data into the GRASS native format. You can just read them. You can just read the files or the external data sources directly. This functionality was significantly improved. That I mean, this reading process of external data sources was improved like 5 times. It's faster. For workflows where you're just reading like portion of the data, the improvement can be I mean really like significant, more than 20 times, for example. So please, next slide. GRASS 8.3 also comes with improvements related to the source code maintenance. We fixed a lot of compiler issues. We also reformatted C and C++ source code using a CLang formatting procedure, and we also improved the CI in this regard. So there is also effort to parallelize a lot of GRASS tools. So it's like ongoing long-term project. Please, next slide. I will present a new tools which comes newly with parallelization support in GRASS 8.3. There are 5. Three are written in C. We use OpenMP I mean, to support parallelization, and there are 2 Python tools which were also parallelized. So please, next slide. But I mean, beside of these 5 tools which were presenting in the previous slide, there is a bunch or number of tools which are already parallelized, including a GRASS Python API. Yeah, but a better graphical user experience. I mean, it's an important topic for GRASS, of course. In version GRASS 8, we did really like a huge change, because I mean, for dozens of years, maybe from starting with version GRASS 5, there was a welcome screen, and it was obstacle for many newcomers. So after really long discussion, we decided to change this concept. So in GRASS 8, there is no welcome screen anymore. Please, next slide. Next slide. So no more. So how GRASS starts? Starting with GRASS 8, GRASS just opens like a demo project. And what is important, we are trying to navigate first or newcomer to 2 next steps, because I mean, what is important that the user understands that this demo project is not, shouldn't be used for real work. You should create a new project, import your data, and continue. I am using here a term project, but I mean in the GRASS terminology, we are calling or we are using a term GRASS location. So project is not perfectly correct, but maybe it's more understandable for I mean, newcomers to GRASS. So we changed this concept completely, which was, I mean, really huge change for GRASS starting procedure in a graphical user mode. But of course, I mean, the GRASS power still stands, I mean, in the command line that you're using GRASS on the server like a computational engine. But also we are taking care about users who want to use a graphical user interface. I mean, both groups of the users are very important for us. So with GRASS 8.3, I forgot to mention this part. Beside of like changing how GRASS is starting, we also, I mean, traditionally GRASS GUI is multi-window layout based. So you start the GUI and you just multiple windows pop-ups. We also introduce support for single window layout. And in version 8.3, this year of the new version I am presenting here, this single window layout is by default. So if you just start GRASS first time, you will get this single window layout. So please, next slide. Also, we did a lot of improvements in this single window GUI. Here on this slide, there is like a GRASS Mini project. I will be speaking about that in the next slides. So you can see that I mean we changed the layout of the console pane and so on. There are various changes, and please, next slide. I need to speed up. We also improved dark theme support. So if you like to use dark theme, GRASS is supporting that. Please, next slide. And here I would like to highlight contribution from the community. I mean, there are, as I mentioned, there are core tools, but there are also tools which were created by the GRASS community. We call them add-ons, like something like extensions. So let me present a few of them. There is a new add-on which derivates a single elevation value for water bodies based on LiDAR data, done by Anna Petrashova. Please, next slide. Random walk simulation, a tool which allows you to, or which enables you to generate a 2D random walk with multiple parallel walkers and so on. Please, next slide. There's also a tool which allows you to plot or draw box plots for rasters which are registered in the space-time raster dataset. This is like a really important for GRASS. GRASS is very powerful when you are working with space-time data. We have like a framework of multiple tools which allows you to work with space-time data series effectively. There is another add-on which allows you to access a threads data servers in GRASS. Please, next slide. Yeah, so how to be involved? I mean, our community is open for new contributions, of course. Please, next slide. We are on GitHub, so I mean, if you are familiar with GitHub, our project is working in the similar way as other projects. You can create the issues, pull requests, everything is publicly visible. You can discuss on GitHub, discuss pages. Always pull requests are welcome. As my colleague Marco mentioned, we like issues, but we love pull requests, of course. So we also changed the way how we are supporting the GRASS translation. We migrated to OSGeo webplate. So this is, I mean, very important. If you want to contribute to GRASS, please try to improve documentation, tutorials, and so on. This is like very important for GRASS that we have good documentation which can be used and which will be usable for newcomers. You can also contribute by material on social media and also answer the question on GIS forums and so on. So this is like nothing special comparable to other projects we are working in a similar ways as other projects. Please. Yeah, sponsoring. This is also a big issue for GRASS. We love sponsors, of course. You can contribute by your time, you can contribute by money, of course. Organizations can contribute as a regular sponsors and so on. So we are, of course, open for this kind of support as other open source GIS projects, of course. So please, next slide. We have a special program for students. I mean, there is a Google Summer of Code project we are trying to participate. But I mean, what is important that we would like to support students for, longer time, that they can maybe finish something what was not completely finished in Google Summer of Code project and so on. So we have a special program for supporting students. It's also, it includes actual coding, but also, bug fixing, improving documentation, and so on. So please, next slide. Yeah. We celebrated GRASS 40. We did our best. We met in Prague. There was a GRASS community meeting. So we enjoyed a lot. We celebrated a lot, as you can see. Please, next slide. So we met basically 1 month ago or 3 weeks ago in Prague. And yeah, we spent 5 nice days just doing what we like. I can see few of participants here. So I hope that you had the nice time as me. So please, next slide. So as you can see, beside partying, yeah, we did a lot of work. Next slide. Party. Yes. And we need to thank our sponsors, of course, because without of them it wouldn't be possible to organize such great event. So thanks to OSGeo, thanks to FOSS4G, thanks to OSGeo Japan, and very importantly, many individuals. So and also thank to Czech Technical University for providing a venue. Next slide, please. And I will just show some outcomes. Please, next slide. So we released H3. Next slide, please. We did some progress in translation to CMake. GRASS is using auto tools, so we are trying to move to CMake. We also move Docker images to the official OSGeo Docker Hub organization. Please, next slide. Yeah, we did improvement in graphical modeler, so now it's integrated into the single layout window. And we also did the first step to convert our manual pages in HTML to Markdown we improve or it will be easier to maintain the documentation also for outside contributors. So please. And also my colleague added a new export functionality to GRASS GIS modeler related to Actinia. Yeah, thanks for your attention. There is some bonus slides, but we don't need to show them. I hope that I was able to present the important part. So thanks for attention.
Let me. I would like to know something about the soil line slope for vegetation index.
Yeah. Maybe, I mean, what is maybe better that there is a colleague of mine who did this improvement, so he can explain better. Generally speaking, I.VI is a tool for computing dozens of vegetation indexes. So it's not only it's not only about soil slope support, but I mean it's the tool which really enables to compute different kind of indexes, vegetation indexes. So maybe let's keep discussion about this specific issue during a coffee break. I think it will be a perfect occasion. So don't hesitate to catch me, and we can discuss it later. Thanks. So thank you.
So let's give Martin another round of applause, and we move on. Is Evan, there you are, very good. So the next talk will be State of GDAL versions 3.6 and 3.7. And the talk will be given by Evan Rouault. I hope I pronounce it correctly. Can we switch the talk, please? What? Okay, it's coming.
They are rebuilding GDAL probably.
Okay, Evan, the floor is yours.
Thanks. So my name is Evan Rouault. I'm an independent, free, and open source developer, mostly focused on GDAL, map server, QGIS, and Proj. And I'll give you now an overview of the changes GDAL has received in the last GDAL 3.6 and 3.7 releases. And I'll talk a bit about the future directions too. Next slide, please. So what is GDAL in just one slide? So first it stands for the Geospatial Data Abstraction Library, which is a black box you use often without realizing it when you want to read or write geospatial formats in most C or C++ open source or closed source GIS software. As of today, it handles more than 250 different formats or network protocols and services. It is released under the MIT open source license, which is super permissive. And we release a version every 6 months with new features, and bug fix releases every 2 months. Next slide, please. Yeah, next. Thanks. So one of the major items of the GDAL 3.6 version has been the full transition to the CMake build system. In GDAL 3.5, it was introduced in additions to the existing Auto Tools and Visual Studio and Make build systems that existed since forever, but showed their age. And CMakes offer many advantages. In particular, offering a single cross-platform solution with good integration with many third-party tools. And the transition to CMake went really well. So as of today, it's not the only build system available. We have an extensive documentation of all the build options, which are mostly related to the dependency of GDAL, and also how to build drivers as plugins or to skip drivers from being compiled. GDAL has supported the S3 file geodatabase format for a long time, first through a driver which used the closed source SDK, and many years ago we came with the OpenFileGDB driver, which is a fully open source driver without any external dependency. So this driver only supported read operations until now, but we managed to complete the reverse engineering to the point where the format was very well known and we could add write support. So in GDAL 3.6, you can do whatever you expect from a GDAL driver with write capabilities. You can create a new file geodatabase, add or remove layers to it. You can add, update, or delete attributes, features. You can create spatial and attribute indices, as well as more advanced functionalities such as the support for field domains or layer relationships. And quite fun fact, the basic licensing of the proprietary vendor software doesn't even offer that functionality. So with GDAL, you can do that for free. So Niall Dawson from QGIS also integrated those new capabilities in the QGIS user interface. So from the QGIS browser, you can easily explore, credit, or edit a file geodatabase. So still related to file geodatabase in GDAL 3.7, we have no read support for raster datasets. This functionality was not available in the proprietary SDK, so there was really no easy solution up to now. You had previously to use an external tool, the Ask Raster Rescue utility, and so now its functionalities are fully integrated as a GDAL raster driver with all the things you expect, like being able to read the CRS and the georeferencing, access just a part of the tiles, or have pyramids for fast multi-resolution display. The driver also supports all the compression methods, and you can access the value attribute tables as a GDAL raster attribute table. So the current version only read the raster datasets that has been produced by ArcGIS 10, and in the next GDAL 3.8 version, you will be able to read datasets from ArcGIS 9. Now let's talk a bit the topic of columnar-oriented vector reading. So in GDAL 3.5, we had two new drivers for the Parquet and GeoParquet and Euro columnar formats that were only using the traditional OGR feature-based API. And so what is important about this Euro-based thing is the whole ecosystem that is around it. So you have many Apache projects such as Spark, Drill, Kudu, and Parquet. And you have also other projects that use it to facilitate exchange between different software. You have Pandas and GeoPandas. You have our spatial ecosystem. You have TileDB, which is a multidimensional sparse and dense array storage solution. You have DuckDB and now GDAL. So you may wonder, what do we call exactly a columnar-oriented representation of a table? So here we use this really simple example of a table with 4 rows and 3 columns or attributes. So you have one attribute with an object ID, another one with a timestamp, and the last one is a geometry. Here it's shown as a WKT, but generally it will be encoded in a binary way for efficient processing. And so in a row feature-based memory buffer, you will find the data for each row, column by column, and followed by the data for the second row, and so on. Whereas in a columnar memory buffer, you will first find all the data for a given column organized in a consecutive way in memory, which enables better compression and as well using the superscalar capabilities of CPUs. So concretely, what was implemented in GDAL is a new method in the OGR layer class, which returns a narrow stream C structure. So a narrow stream C structure is a standardized API that enables the user to get the schema, which is a set of attributes with a name and types. And then you have a getNext method where you can iterate through the data through batches of many features organized in a columnar way. And I should also mention that despite the arrow in the name, there is no dependency to the arrow C++ library. It's just a set of C structures which are shared by the many projects and unable to exchange data. So there's no runtime new requirement. It will be available in all GDAL builds. If you use a Python API, you have two new methods. One which returns data using the structures of the PyArrow library, and another self-contained implementation which returns data as a set of NumPy arrays. So previously we discussed about the API. Now let's check a bit how it's implemented. So there's a generic implementation which is available for all OGR supported drivers, even those who don't specifically implement the new API or which are not even columnar oriented. Of course, there are some overhead in doing this bridge between a row-oriented API and a columnar representation. But if you're going to do it at some point, it's better to let GDAL do it because for some of the drivers, you may have an optimized implementation. You have also the drivers which have this optimized implementation. Of course, you will find the Parquet and Euro drivers. You also have a TileDB when you want to read TileDB sparse arrays. And the GeoPackage and flat GeoBurf drivers have been improved to have a specific implementation of the Euro API, even if they are not columnar oriented. And this saves the overhead of the generic implementation. Oops, sorry. So what about performance? Here I've listed the timings for loaded quite large data sets, which is made of 3.2 million records with bidding footprints of New Zealand, and each record has 13 attributes. So you can see in the list that for the two listed formats, Parquet and TileDB, you can get a 4 times to 6 times performance improvement factor using the Euro API, which is expected given that those formats are columnar oriented. And we also have heavily tuned the GeoPackage implementation, and it performs extremely well. It can be even be slightly faster than GeoParquet in multi-threading mode. Of course, there's some trade-off because Parquet compresses very well, whereas GeoPackage has no native compression. The flat GeoBurf implementation also brings substantial performance improvement. And for good measure, I've also listed shapefile Shapefile has no dedicated implementation of the new API, so it goes through the generic translation layer, and here you can see that there is a 1.5 times slowdown. So what about the new drivers added in the recent version? In GDAL 3.6, we added two closely related drivers that deal with GPU optimized textures formats. So there's a basis universal format and the KTX2. Those formats enable a very quick translation between GPU compressed and compressed texture formats. To be noted, though, that the GDAL driver only uses CPU-based encoding and decoding routines. And since GDAL 3.5, we had support for the JPEG XL compression. This was only as a TIFF codec until now, and now it's a freestanding driver. So when you have a JXL file, you can open it. And JXL is a new compression method that competes with modern codecs such as AVAF, HEAF, or WebP. It has two modes, lossy and lossless mode. And the lossless mode is quite interesting if you're dealing with 12 or 16-bit data. And so like the TIFF JPEG XL codec, it relies on the open source libjegxl library. In GDAL 3.7, the NSIDC bin raster driver has been added. So this is a driver to access the raw binary format for sea ice concentration data sets that are produced by the US National Snow and Ice Data Center. There's also a new OGR driver for the GTFS format. GTFS is a general transit feed specification, and it's used for public transportation schedule and their associated geographic information. So the driver exposes text tables with proper attribute typing, and it also builds OGR geometries for the stations and trips. OGR info, which is a utility you use to get access to the structure and the metadata of vector layers, has been enhanced to be available from programming languages. So the main function is a C function, GDAL vector info, which is accessible through Python and all the other swig bindings of GDAL. But the main addition is a new JSON-based output that you can get with a -JSON switch. So now you can get information about the geometry types, the CRS, field definitions, and every other output of OGR info in a machine-readable, friendly way. So you don't have any longer to use grep or awk or any other hand parsing of the OGR info output. In the random category, I should mention the OGR layer algebra script that is now available as a fully official utility. So this utility can compute intersection, union, differences between two layers. The OGR layer API has also been improved with two methods to modify features. And in particular, the update feature methods can bring substantial performance improvements for drivers that implement it. So currently we have the MongoDB, PostgreSQL, and GeoPackage drivers that implement it. And for GeoPackage, In some cases, you can get to a 4 times performance improvement when you want to update, for example, just one single attribute in millions of rows. The PNG decompression has been also substantially improved. So you can get almost a 2 times acceleration factor, and it's available in the PNG and all drivers that use PNG, such as GeoPackage Raster, WMS, or WMTS. There's also a new framework which has been added in the Raster API to be able to directly access compressed data without decompressing it, and so it enables to losslessly convert between different formats that would use the same codec, for example, JPEG or JPEG XL. What has been implemented for now is a bit limited, but the API could open the door to lossily convert from a GeoPackage using JPEG compression to a tiled GeoTIFF using JPEG compression as well. So for those who heavily use TIFF or cloud-optimized GeoTIFF, you will maybe be interested in this performance improvement in the GeoTIFF driver. So when you want to read several tiles at once, it can parallelize the decompression, and in the best cases, you can have up to 5 times faster decompression. I have another talk later today about SOZIP, which is an enhancement to the zip format, which enables to read random parts within a big compressed file in a zip, and it has quite interesting use cases if you have gigabytes GeoPackage files and you want to be able to use them directly from the zip. So to almost conclude, let's have a quick look at the GDAL 3.8 versions that will be released this November. We'll have a driver to read the OGC feature and geometries JSON format, which is an extension of a GeoJSON that adds CRS support. You also have time and 3D geometries. There will also be a new driver to handle vector tiles encoded in a PM Tiles archive. So PM Tiles is a cloud-friendly tile container that enables you to serve tiles efficiently from an object storage. And the TileDB driver will also be enhanced with an implementation of the multidimensional API. So let's not forget to thank the sponsors of the project, which make it possible to have a daily bug fixing and timely review of contributions and monitoring of security issues and regular release management. And that's all. Thanks for your attention.
Dietrich?
At 12:30, we're going to start the lunch. The lunch will be way over there. So if you know the way, lead the crowd. If you don't know the way, follow the others. And we've been asked to, stay within like a 20-minute slot at this restaurant because we're very many people. This restaurant is quite small, so that everybody has a chance to have a decent lunch there. Okay? Questions, finally. Very good.
There we go. Can you talk a little bit about how development is going in terms of new contributors or day-to-day contributors and how that's kind of been happening over the last year?
We have two part-time funded maintainers, and we also have people working on the regression test suite to improve it and make it more reliable and modernizing it, which is very important for a project of the size of GDAL to have a really big and extensive and reliable test suite.
We continue at 12, so to give the other people that may want to listen to that talk and they're somewhere else a chance to be here on time. Thank you. Hello, is the next speaker around? He will come. Good. Okay, we can move on. So next talk and the last talk for this session before lunch is Demystifying Re-Earth, a technical examination of no-code web GIS platform. And the talk will be given by Komiya-san. Go ahead, the floor is yours.
Hi, thank you for coming today. It's actually been 4 years for me for attending last FOSS4G. It was like FOSS4G NA North America in San Diego. Yeah, thank you. So, yeah, here's today's agenda. We're gonna talk about how re-earth works and also how re-earth solve the issues of the world. So I'm gonna introduce myself. I'm a co-founder of Eukarya. Eukarya is a company developed re-earth. And I'm based in New York City right now for 3 years. I'm from Japan, Tokyo. My background is like design and engineering, also art, science. So what is re-earth? So re-earth is an open source GIS platform that allows you to visualize or analyze every single issues and also without coding. So everyone can use it with no requirement, like install softwares or like knowledge of coding, JavaScript, anything. And also you can use it for making storytelling or the data visualization or data analysis. And sometimes we collaborate with a company like, who has IoT solutions or real-time connection through the sensors installed city. So here's a video, still waiting. Okay. All right, so here's a video that shows how you can control re-earth. So you can see some information on the left side that it's kind of like a layers of Photoshop. So you can just drag and drop the materials on the map and you can put the pin and also you can edit the content of the pin. You can put any like a text or images or videos in it. And also you can put any 3D models like Pikachu's 3D models or other cities 3D models like city GML or I mean like 3D tiles or something like that. You can also change the layers of the tile. For example, if you want to use like your own map box design map, you can also switch it. Then we are developing a feature for switching web engine itself. Right now, we are using CZIM.js for 3D map or 2D maps, but in the future, maybe in this year, we can switch from CZIM to Mapbox or Leaflet or other kind of map engines. So what is the hard thing about the GIS? I mean, GIS is, of course, everyone knows like a GIS is too complicated. So there are so many requirements or so many knowledges. And also, there are so many departments, I mean, the industries we can apply. Also, 3D models, I mean, 3D map is more complicated. We have another dimension, and also we have another algorithms to analyze these data sets. Also, it's expensive, I know. So that's why we are focusing on like a more accessible or like more extensible for non-engineer people. So then what leaders can do, we have a bunch of examples that shows, for example, disaster management or city planning or digital twin. I don't want to say the word metaverse, but it's this kind of stuff. And also community development, like citizen engagement stuff. So I'm gonna show you some example here. So this is a disaster management example that shows like the flood situation with time series data. You can see the evacuation route. The green point and green line shows like where you are and also can you evacuate to the shelter depends on time series data. So the blue polygons show the flood situation. So right now, there is no route to evacuate. So that's why, how fast you gotta escape, that shows. Like Japan is famous, known for disasters like flood, earthquake, or typhoon. So that's why we have a bunch of examples in that way. So we also have a collaboration with company who are developing the robots. And then you can also manipulate robots in the buildings. For example, this one. This shows like a BIM models. BIM is known for, like a building construction company. If they want to make a building models, it's more complicated. Detail. Like there is a pipe on the ceiling or something. It's kind of different from like a GIS format. But we can also collaborate with this kind of data set in our platform. So it means you can, for example, if the robot is going into the building and also going outside of the building, for example, on the road or public space. But if you want to do this kind of stuff, you need like two different softwares for now. But you can also use this one, only one software to build this kind of application. We also have like a citizen engagement example. This is the example like collaborating with Japanese high school or junior high school student, and then they are doing their field work to find some like issues of the cities or town. And then they plot the data set. I'm sorry, it's kind of like hard to see here, but it shows like a bunch of like issues on the of their cities, and also everyone can put without coding. Also, and then we can share the project. I didn't mention that, but readers can share your project just clicking publish button. And then you can also share the URL to everyone. And then every single citizen can see what the issue is. So now we have 50 plus organizations use Re-Earth and also 100 plus project. And we have a Discord community that has more than 400 members there. And we also held a workshop yesterday, and then thank you for coming. Also, they're also joining our members now. Collaborate community, yes. So our price for subscription model, like cloud native application, is starting from 6,000 per year. That means like a 500 USD per month. And then you can also use a file storage or plugin system, and also plugin marketplace. The plugin marketplace is for installing other one's plugins, like WordPress plugin. But if you're an engineer, if you can host yourself, it's free. Open source version is also available. So you can go to GitHub, and then you can just download our source code and also Docker file. You can just host your own Re-Earth as well. So there is another example that is our biggest example, and we also have another booth on the main venue, and it's called Plateau View. Plateau View 2.0 is hosted by Japanese government, Minister of Land Infrastructure and Transportation. And then we have more than 30 local governments, and they deal with their data set. And Plateau View focused on data set. I can show the video first. So there are a bunch of 3D models with textures. It's all hosted by Japanese government, and it's all free. So you can just install the huge data set, and each building has a metadata. So you can see, for example, like how high the building can stand from flood or earthquake or something like that. And you can use this one for game or like a flood management or other kind of city development stuff. But you know, this data set, of course, it's huge. So that's why it's kind of hard to manipulate by non-engineer people. But if you use Re-Earth or like our software, you can just drag and drop the data set, or you can just visualize the huge data set. Okay. All right. So as I mentioned earlier, we have a plugin system. The plugin system allows you to develop your own features. For example, like if you want to build your niche idea, but Re-Earth didn't support that, you can also develop by yourself, or you can ask us to develop our new features. It's kind of like same as a WordPress plugin. And also, the Plateau view I showed earlier is also built on our plugin system. So you can do this kind of stuff, like, I mean, almost everything you can do. So we have communities for developers or non-developers. For example, first one is Discord. We have English or Japanese support right now, and then you can ask everything, questions, or you can share your project there to appreciate your work. And also, we have documentation for open source software. You can see how you can use Re-Earth there. Also, we are contributing open source software, not only Re-Earth itself. Re-Earth also in the GitHub page. And also, we have another open source softwares. Here, I showed one of the examples. Here, it's called Resume. If you're a React developer and Cesium developer, you can use this library for wrapping Cesium on React. It already have 500 stars, and then yeah, I'm so glad to share this, because like I also made this by myself. So we have a bunch of ecosystem. It includes like a future ecosystem as well. But we have a CMS right now, and also plugin marketplace. Also, we are building a switching feature of the map engine, like from Mapbox or Cesium or MapTitle, etc. And then we are also making the AR solution. So for example, if you put this any 3D models on the map, you can also see the actual model size in real life when you go there. And we are looking for people or organization or company who want to share your data set or plugins on Re-Earth system. So just let me know if you want to do this. So how Re-Earth works, it's the technology part. So we have this kind of ecosystem. So I'm going to introduce one by one. So we use TypeScript and React and Golang for languages. So TypeScript and React is used for front end and also UI design. And TypeScript can allows us to develop a huge project like this one. Also, Golang is also the fast languages for backend. And then, of course, we use Cesium. We're just selected as a Cesium certified developer last month. And yeah, so that's why we have a bunch of Cesium professional engineers in our company. So we are kind of focusing on Cesium right now, but not only Cesium in the future. So we also use a GraphQL that is not SQL, but it's kind of like an API for calling the dataset from database without scheme, and also being able to request only the necessary portion of the complex data set or nested data set in a single request. That is super nice. And also, you don't need to call like unnecessary data set in one request. We use a MongoDB for database, and it's an OSGeo database, easy to scale. RIERS has a complex data schema, but it depends on what you want to do. So that's why we chose this kind of like a NoSQL schema database, no schema database. Also, infrastructure part, we have a Docker system, so that allows you to scale your infrastructure or connectability. You can also duplicate at the same environment, super easy, and also it's light. We also use an OpenID Connect for authentication system. We use JOT token for token encoding and a signature mechanism. We also support this OpenID Connect as well. And here's a big thing, this is a WebAssembly. WebAssembly allows you to develop your plugin with safe and light and fast. So I'm gonna introduce about plugins more later. So the previous issue of RIERS was, like a no-code tool looks or sounds super nice, but sometimes it's kind of like, too simple to solve your problem. So it's not perfect, I know. But, we would like to expand that kind of features with plugin system. So plugin system allows you to develop your own feature. That means you can, develop your niche idea. So, but the plugin system is, saying this kind of stuff is easy, but developing this is too hard. So what we did is, thinking about our plugin system, and also there is a system called QGIS. There is a library, QGIS EM scripting. It's a WebAssembly library that allows you to use WebAssembly on the web browsers. But it's kind of like a low-level API. It's not for us. So that's why we made our own open source library. It's called QGIS Encryption Sync. And then we use the system for plugin system, and then we released the plugin system 2021. So now you can see the plugin system on plugin marketplace or on RIERS. So how plugin works? So you can see the models that shows like how RIERS deal the plugin system. So the RIERS front end get the source code from RIERS server, and then QGIS dissolve the content of the plugin, and it return to the front end. Then also we use like an iframe for describing the data set, describing the plugin. For example, if you have your own UI on RIERS, you can also build this with plugin system, and you can talk between CZIM, or like a map side or an UI side, and you can connect the data set as well. So yeah, today I want to talk about why we need a no-code and WebGIS. So we have a bunch of developers in our team, where they are also from, country who it's kind of extreme situation. Like these three guys are from Syria, and they are still there, but they're not. They are refugees, but they are so super good engineers. But it's kind of hard to contact. Hard to reach this kind of tools. There are so many restrictions. So that's why why we are developing the RIERS is we want to reach this kind of open source software for extreme people. For example, like refugees or single parents or something. And also no code allows you to develop or participate this kind of developing or creating a content with it. So it's not like just an open source software. It's called like a digital public good. It means it's not only sharing. We also support them with this stuff. So the current work on RIERS is we are developing the CMS that allows you to store the complex data set like a GIS stuff. And also we have the RIERS Flow. RIERS Flow is like a data conversion and analysis system. It's a GUI system. You can convert that data set from, for example, the complex one like 3D GML to 3D tiles or something. Also, we are developing an AL system that's, you can put your URL on the application and you can see your project in real life. And then we have a library with Python library, and that allows you, for example, if you're an engineer or if you're an analyst, you can also use, for example, Jupyter Notebook for analyze your data set. So if you want to use RIERS for now, you can just search riers.io, and then you can click top right button. It shows Start Now. You can sign up there. So we also are hiring. We're hiring the developer or project managers or other sales all over the world now. Because I'm the only person who are based in New York City. I'm so sad right now. So we are gathering the people. Yeah. Just let me know. And also, we have a bunch of sorry, this is a previous one. Sorry, yeah, these two are already gone. I mean, the middle one is this one. But we have another session on tomorrow, I think here. And then it shows like how like a FOSS4G contribute to the new employment opportunities. And also we have a code sprint on Saturday and Sunday. We don't know the place yet, but yeah, you can just search on the FOSS4G website, and then we'll see there. If you want to develop your plugin by yourself, you can see how it works there. Yeah. Also, we have like a non-official party on Friday. You can sign up here. We're gonna hold some parties to just come, for the conversation with other open source softwares, contributors, or other GIS users. Yeah, we are happy to come welcome you guys. Thank you so much.
Okay, do we have questions? Everybody's waiting for lunch? No questions. Okay, if you have no questions, then nobody wants to stay between you and lunch. Again, please remember, try to stay to your 20-minute slot at the lunch place so that everybody has a chance to sit there and have a good lunch. And then let us thank Hamid Reza, my co-chair. Let us thank Kumir-san again and all the other speakers in this session. And have a good lunch.
Thank you.